Chemistry powers today, but courageous chemistry is shaping our tomorrow. It's fueling the hydrogen economy and driving clean energy. It's in our semiconductors and even powers our 5G. It makes bridges stronger and medical equipment safer. Chemistry powers progress and binds us all together. But there's something more that sets us apart. Courageous chemistry.
Hello and welcome to today's lesson. In today's lesson, we'll look at the periodic trends of the periodic table. That is the pattern in which the properties of the element follow. We already know that the periodic table is arranged in rows and columns, and they have 10 main divisions, which of course are your alkali metal, your alkali earth metal, your transition metal, your post-transition metal. You have your metalloids, your lanthanide and your actinide series, non-metals, halogen, and then the noble gases. Is it not? Yes. Mendeleev arrangement of the periodic table shows something deeper, that elements in the same group tend to exhibit the same chemical properties. Okay, and not only that, the property is periodic, but this property follow what? Trend. Okay, so look at 5 major properties and the trend in which they follow. There are 5 major trends or properties that we'll look at that follow these repeated patterns. They are electronegativity, ionization energy, electroaffinity, atomic radius, and metallic what? Character. What is electronegativity? Electronegativity is simply defined as the ability of an atom to attract what? Electrons. Okay, the ability of an atom to attract electron. There is an acronym for it. You can say electronegativity is electron attractability. All right. Generally, the more electrons are attracted to an element, the higher is electronegativity value. 2 factors that play important role in electronegativity is the atomic number and what we call the ionic radius, or simply the distance of the valence electron from the what? Nucleus. Elements tend to attain their octet or stable configuration by either donating electron in the case of metal or accepting electron in the case of non-metal. Looking at group 1 of the periodic table, you discover these elements have just 1 valence electron in the atmosphere. So the tendency to, gain electron is more difficult than just what? Losing them. So in this case, they will have low electronegativity values. Not? Francium is considered the least electronegative element, and sometimes it is replaced with cesium depending on which scale you are using. Alright, now as we evaluate francium carefully, we discover that it has atomic number 87, meaning there are what? 7 electron shares. Not? We have the first share, the second share that can take, third share, fourth share, fifth share, and they can take the corresponding electron, as you can see. Now, getting to the 7th share, you discover there is just 1 single electron in the atmosphere. Therefore, it will be much more difficult to fill the octet structure, okay, with 7 electrons than to release 1 electron and attain stability. Hence, metals at the left tend to be what? Less electronegative. Is it not? The same case is with what? Cesium. You can see it has 1 electron in that atmosphere. Another effect we call shielding effect also contributes to this. To my right of the periodic table, just after the transition series, the reverse is the case, because here elements tend to what? Gain more electron to complete or attain their octet configuration. The most electronegative element is what? Fluorine. Is it not? Yes, due to its what? High tendency to accept electron. Is it not? Yes, and attain its octet structure and also its electronic configuration. Now, there are exceptions to these rules. What are the exceptions? What you are seeing highlighted there. The transition metals, the actinide and the lanthanide series, and then the noble gases do not follow this rule due to their high stability, while the transition metal is due to their metallic properties, and then the actinide and the lanthanide series do not really follow this rule. Alright, let's now analyze the property from left to right. You will see that electronegativity does what? Increase. Is it not? And then from bottom to top, it also increase. In other words, from up to down, it what? Decrease. Alright, so the higher the electronegativity number, the higher the ability to attract what? Electron. Let's look at a scale known as Pauline's what? Scale. It is used to determine the electronegativity. Okay, for the least electronegative element it is 0.7, which is a francium. Okay, while for the highest it is about 3.98, which is fluorine. Okay, take note of that. Let's look at another property known as ionization energy. Ionization energy is the energy required to remove 1 mole of electron from a gaseous what? Atom. It's called the first ionization energy per se. So if you are removing the second electron after removing the first, it's called the second ionization what? Energy. We remember ionization energy using the word electron removization energy. Okay, just allow you to remember that it actually involves removing what? Energy. The lower the ionization, the more likely that element will form a cation, okay, or turn into a positive charge by donating what? Electron. Why the reverse is the case, is it not? Yes. Because if we go back to our periodic table, we discover that the element which was first discovered in the sun, known as helium, will have the highest ionization what? Energy, is it not? Yes. Whereas francium will have the what? Lowest. Now look at the periodic table carefully. You see that helium is at the top right, while francium is at the bottom left, is it not? Why? Because of an effect known as what? Shielding effect. Can you see it now? Shielding effect simply means that the electrons that are the middle of francium are shielding the single electron that is outside at the outer shell from the nucleus. Do you get it now? Yes, this is what I'm saying. The attraction between the single electron at the last shell is very weak because of the shielding effect of the middle what? Electron. Do you get it now? So generally from left to right, the ionization energy will what? Increase. Similarly from bottom to top, the ionization will also what? Increase. That is, as you move down the group, ionization energy also what? Decreases. Take note of that. Let's now look at electron affinity. An ability to form negative ion. It is the amount of energy released when a neutral atom accept or acquire a negative charge to form a negative ion. Okay, generally as you move from left to right, it increases, is it not? And as you move from what? Bottom to top, is also what? Increases. That is, up to down, it decreases. Take note of it. So the more negative electron affinity, the higher the attraction of the electrons, that is non-metals, is it not? Why the reverse will be for what? Metals. From this explanation, it implies that fluorine is supposed to have the highest electron affinity, but in reality it is chlorine, not fluorine. But why? The secret lies in their what? Electronic configuration or structure. Okay, you can see clearly that the value for electron affinity for chlorine is more negative than that of what? Fluorine, meaning that it has more electron affinity. Why is that so? It lies in atomic number again. From the atomic number, you get their electronic configuration. Now there is a p orbital. Can you see there? There's a 3p orbital that create more space to fill what? Electron when compared to that of 2p5. Hence, you can see that the size of chlorine will be much bigger than that of what? Fluorine. Okay, you are going to look for the difference between ionization energy and electron affinity, and also electronegativity and electron affinity. Atomic radius. This is the size of the what? Atom. Remember that radius is half a diameter, is it not? Yes. So we'll talk of the atomic radius. I'm talking about the distance of the nucleus of an atom from its what? Electrons, is it not? But there's a problem with this measurement. Why? Because remember that from quantum theory, we only have the possibility of finding an electron in an orbital. That is, the electrons are not fixed. They keep what? Moving. So scientists try to measure the atomic radius by measuring different parameters, such as the what? Atomic, the metallic radius, the covalent radius, and of course the ionic what? Radius, which is the distance between two closest center atom. Okay, now generally the atomic radius increases from top to bottom. Why? Because more valence electron are added and the more energy level are what? Added. Beside the more valence electron and more energy, the shielding effect, which we explained earlier, also play an important role. Okay, take note of that. The shielding effect, where I say the center electron are shielding the outer electron from the what? Nucleus, is it not? Thus increasing the size in reverse. Atomic radius decreases as you move from left to right. Why? Because more protons are added to the same energy level. Hence, there is increase in nuclear attraction, which will attract the outer electron and drag it closer to the nucleus, and in return decreasing the size of the what? Atom. I hope you understand that. So if I move from right to left and then top to down, I will have an increase in atomic what? Radius. Take note that it is the opposite of all the movement we have been seeing since, is it not? Yes. Francium has the highest atomic radius and helium has the lowest. We can remember using these acronyms. Franciums are bigger than the air parts. Franciums for francium, air parts for helium, telling us the what? Biggest and smallest atomic what? Radius. Let's now look at metallic character. Metallic character is the ability of an atom to lose an electron to form a positive what? Ion. Take the metallic character is classified into three. 1. The ability to lose electron to form ions. 2. The ability to form basic oxides. And 3. The ability to lose or react with acid to liberate hydrogen gas. Generally, the metallic character decreases as you move from left to right. Okay, why is that? Because the atomic radius also decreases, and then because outer electrons of smaller atom do not ionize what? Easily. Okay, but as you go down the group, the metallic character will do what? Will increase, is it not? Why? Yes, because atomic radius increases, is it not? Outer electrons of bigger atom ionize more easily, is it not? Yes. Atoms with smaller size have low ionization ability because of the strong attraction between the outer electron and the what? Nucleus. Unlike those bigger atoms that has less attraction between the nucleus and the what? Electron. So generally, if we move from right to left of the periodic table and then from top to bottom, then the metallic character will do what? Increase or increases, is it not? Yes. Memorize. Okay, we can use this following to memorize what we have learned so far. Electronegativity, ionization energy, and electron affinity all follow the same trend. That is, as you move from left to right and bottom to top, it what? Increases. Do you get it now? You can memorize this by using the term negative ion affinity up to the right, telling us that is what? Increasing. Do you get it now? Both the atomic radius and the metallic character increases from right to left and top to bottom. So you can remember it by saying radiometallic down to the left. That now brings us to the end of today's lesson. Remember to do your assignment. Okay, see you soon.